So let's look at something that's a little more complicated. Let's go back to the dice. So I have a six-sided, and the singular is die, plural is dice. So I have a six-sided die, right? This cubey thing, and the cubey thing has numbers on it, like a 1, and a 3, and a 5. So here's my rendition of a dice, and we're going to roll it. And so there's lots of things I can ask. Like a minute ago, I asked, hey, what's the probability of getting a 3? Well, that's a 1 out of 6. What's the probability of getting a 4? That's also 1 out of 6. But we could have more complicated events than just getting a 4. Like I could say, hey, what's the probability of getting an even number? All right, well, what does it mean to be an even number in this case? Well, there's a 2 on there, or I could have gotten a 4, or I could get a 6. So there's 3 different even numbers I could get. So the probability of rolling an even number is 3 out of 6, or 1/2, or 50%, or 0.5, right? Lots of ways we can write it. With probabilities, I sometimes don't bother reducing them. Like this isn't okay to state an answer for a probability, because it shows me, hey, there were 3 favorable outcomes, there were 6 total outcomes. And then sometimes I'll just go straight from that maybe to the decimal or percent version. So it's okay, in my opinion, to not reduce probabilities sometimes, because again, they show us favorable outcomes and total outcomes. Other thing I could ask is, what's the probability of getting a prime number? Let you guys think about that for a minute. See if you can come up with a number for me. What is the probability on a 6-sided dice of rolling a prime number? And there's all kinds of online dice roller apps. There's one like random.org that I like. Google used to have one. Why didn't it pop up? Roll dice. There we go. Thank you, Google. Hey, I got a 6. Isn't that cute? Rolls it around. Whoa, making me dizzy. I got another 6. What the heck? Hey, I got a 5. All right, anybody got a number for probability of a prime number? 3 out of 6 says Monsi. Okay, let's see. I'm going to put down the sample space just to be clear. I think that is correct. Sample space is a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And in this case, I could list the favorable outcomes by identifying which of those are prime. 1's not, but 2 is. Or 3 is prime. Or 4 is not, 5 is, 6 is not, 5, and Monsi is correct. It is 3 out of 6, or 50%. So there's a 50% chance of rolling a prime number. Hey, there's a 50% chance of rolling an even number. Is this true? Question mark. What's the probability of rolling an even number or a prime number? Since they both are 50%, is that, question mark, 100%? Seems like that might be possible. What do you think? Prime or even? Let's see. Is there any number that's not prime, not even? I think I see a flaw here. Anybody else? I don't think it's 100%.
So it has to be even or prime, but it can't be even and prime, like number 2?
Ah, good question. So in math, or is in, and I talked about this way back in 211, it's been a while, or is an inclusive idea. So in regular language, or is exclusive. So like if I say, hey, you can have cake or ice cream, the implication is I can have cake I can have ice cream, but I can't have both. In math, the or is inclusive, which means one, the other, or both. So sometimes a mathematical or in regular language could be written as and/or. So you could have ice cream and or you could have cake. Oh, cool, I could have both. I want both. So in this case, prime or even is any of the number that's even, any number that's prime, but it could be both. So if I list those out, the even numbers were 2, 4, and 6. Now I'm not going to list 2 again because I already wrote it down. So then I would write 3 down and 5 down. Oops, that's not 5. So these are all of the numbers that are even or prime. 2 happens to be both. There are 5 of those numbers, so the probability of being even or prime is 5 out of 6, which is not 100%. So we do have to be careful when we combine events if they're not simple. If they have any kind of overlap, like we have here, then we run the risk of double counting when we throw them together with an or. So an important rule in probability that gets to that, and we looked at this rule way back in set theory, so I'm going to bring up some set theory stuff here from the first quarter. Remember set theory where we drew these Venn diagrams? So this is my sample space here. And in my sample space, I had this event called even, and I had this other event called prime. Come on, Gary, draw it better. That's a little better. And this one was here was called prime. And my universe here is just the numbers on a 6-sided dice. So 2 is both even and prime. It has to go there. 4 is even but not prime. 3 is prime but not even. What else do I have? 5 is prime. 6 is even but not prime. And then there's 1, which lives out here. It's neither even nor prime. So it goes outside the box here. So Venn diagrams can be helpful in doing probabilities. So the probability of being even, I'm going to use even and prime. 2 is the only number that fits that description. So that probability is 1 out of 6. The probability of just being even, we looked at earlier, that is 3 out of 6. The probability of being prime is also 3 out of 6. And these 3 events go together to form the probability of being even or prime. So that would be the probability of being even plus the probability of being prime. The problem with just writing this right here is they both counted the 2. So then we have to say, okay, let's remove that double count by saying remove what they have in common. Even and prime. And this idea is true in general. So in this case, I get 3/6 plus 3/6 minus 1/6 gives me the 5/6 that I found a slightly different way. And this is a general rule for probability. For any events, let's just call them event A and event B, and think about the Venn diagram. So if we use a Venn diagram to think about this, here's event A, here's event B. They may or may not have an intersection. This could be empty here. But in general, the probability of A or B happening is equal to the probability of A happening plus the probability of B happening minus the probability that they both happen, A and B. Remember before we talked about the or, that's a union in set theory, and the and is what we talked about way back, it's an intersection. So those ideas of set theory that we looked at long ago are super helpful for probability. Other things that are important related to set theory and probability, a complementary set So we might have some event, and I'm just going to call it A. It could be, for example, even. Then there's the complement of A. Which is everything that's not in event A. Right, so not even. Venn diagram-wise, if this is event A in here, then the complement of A lives outside of there. Maybe use a different color for that. And there's lots of different ways to do a complement. Usually I put a bar over it. So the complement of A would be A with a bar over it. Everything that's not A. So sometimes you just call it not A. So sometimes you'll see that, not A. So that's everything outside of it. And together they represent everything in our sample space. So the probability of A happening and the probability of not A not happening, that always has to be 100% or a 1. And so this gives us kind of a cool relationship that the probability of A not happening is equal to 1 minus the probability of A happening, or vice versa. Probability of A is equal to 1 minus the probability A doesn't happen. Right, so this is a nice relationship between complementary events. And we do have to be a little bit careful about complementary. In this case, like if I was talking about the dice example again, and A was my even 2, 4, 6, then not even numbers are 1, 3, and 5. And in this case, we have a word for not even. So that works okay. But we don't always have a word for not something. A simple example when we don't have a word for not something is, let's think about the dice again. And suppose we look at prime numbers. And so in here I have my primes, which are 2, 3, and 5. And so let's suppose that's my event A. So A is being a prime number. What is not A? Well, not A is just not prime. Do we have a name for not prime? What do you think? Like not even is odd. Did we ever come up with a word for not prime? Silence. Okay. One thing people often say here is composite. The problem with composite means it has multiple factors composed of many things, but there's also one. The number 1 is not prime and not composite. My point here is just we often have to think hard about what we're doing and don't take anything for granted. Sometimes there is a simpler way to say not something, but often there is not. It's just everything outside of that.